Creating a singleton in Python. This question is not for the discussion of whether or not the singleton design pattern is desirable, is an anti-pattern, or for any religious wars, but to discuss how this pattern is best implemented in Python in such a way that is most Pythonic. In this instance, I define most Pythonic to mean that it follows the principle of least astonishment. I have multiple classes which would become singletons. My use case is for a logger, but this is not important. I do not wish to clutter several classes with added gump when I can simply inherit or decorate. Best methods. Method 1. A decorator. Pros. Decorators are additive in a way that is often more intuitive than multiple inheritance. Cons. While objects created using my class would be true singleton objects, my class itself is a function, not a class, so you cannot call class methods from it. Also for then, x equals y, but x not equal t and y not equal t. Method 2. A base class. Pros. It's a true class. Cons. Multiple inheritance, ugh. New could be overwritten during inheritance from a second base class? One has to think more than is necessary. Method 3. A metaclass. Pros. It's a true class. Automagically covers inheritance. Uses _metaclass_ for its proper purpose, and made me aware of it. Cons. Are there any? Method 4. Decorator returning a class with the same name. Pros. It's a true class. Automagically covers inheritance. Cons. Is there not an overhead for creating each new class? Here we are creating two classes for each class we wish to make a singleton. While this is fine in my case, I worry that this might not scale. Of course, there is a matter of debate as to whether it ought to be too easy to scale this pattern. What is the point of the _sealed attribute? Can't call methods of the same name on base classes using super because they will recurse. This means you can't customize _new_ and can't subclass a class that needs you to call up to _init_. Method 5. A module. A module file, singleton.py. Pros. Simple is better than complex. Cons. Not lazily instantiated.
Use a metaclass. I would recommend method number 2, but you're better off using a metaclass than a base class. Here is a sample implementation. Or in Python 3. If you want to run _init_ every time the class is called, add to the if statement in singleton._call_. A few words about metaclasses. A metaclass is the class of a class, that is, a class is an instance of its metaclass. You find the metaclass of an object in Python with type obj. Normal new style classes are of type. Logger in the code above will be of type _module.singleton, just as the only instance of logger will be of type _module.logger. When you call logger with logger, Python first asks the metaclass of logger, singleton, what to do, allowing instance creation to be preempted. This process is the same as Python asking a class what to do by calling _getIter_ when you reference one of its attributes by doing myClass.attribute. A metaclass essentially decides what the definition of a class means and how to implement that definition. See for example this URL, which essentially recreates C-style structs in Python using metaclasses. The thread What are some concrete use cases for metaclasses? Also provides some examples. They generally seem to be related to declarative programming, especially as used in ORMs. In this situation, if you use your method number 2, and a subclass defines a _new_ method, it will be executed every time you call subclass of singleton, because it is responsible for calling the method that returns the stored instance. With a metaclass, it will only be called once, when the only instance is created. You want to customize what it means to call the class, which is decided by its type. In general, it makes sense to use a metaclass to implement a singleton. A singleton is special because is created only once, and a metaclass is the way you customize the creation of a class. Using a metaclass gives you more control in case you need to customize the singleton class definitions in other ways. Your singletons won't need multiple inheritance, because the metaclass is not a base class, but for subclasses of the created class that use multiple inheritance, you need to make sure the singleton class is the first, leftmost one with a metaclass that redefines _call_. This is very unlikely to be an issue. The instance dict is not in the instance's namespace, so it won't accidentally overwrite it. You will also hear that the singleton pattern violates the single responsibility principle. Each class should do only one thing. That way you don't have to worry about messing up one thing the code does if you need to change another, because they are separate and encapsulated. The metaclass implementation passes this test. The metaclass is responsible for enforcing the pattern, and the created class and subclasses need not be aware that they are singletons. Method number 1 fails this test, as you noted with myClass itself is a function, not a class, so you cannot call class methods from it. Python 2 and 3 compatible version. Writing something that works in both Python 2 and 3 requires using a slightly more complicated scheme. Since metaclasses are usually subclasses of type, it's possible to use one to dynamically create an intermediary base class at runtime with it as its metaclass and then use that as the basic class of the public singleton base class. It's harder to explain than to do, as illustrated next. An ironic aspect of this approach is that it's using subclassing to implement a metaclass. One possible advantage is that, unlike with a pure metaclass, this instance inst singleton will return true. Corrections. On another topic, you've probably already noticed this, but the base class implementation in your original post is wrong. Underscore instances needs to be referenced on the class, you need to use super or you're recursing, and underscore new underscore is actually a static method that you have to pass the class to, not a class method, as the actual class hasn't been created yet when it is called. All of these things will be true for a metaclass implementation as well. Decorator returning a class. I originally was writing a comment but it was too long, so I'll add this here. Method number 4 is better than the other decorator version, but it's more code than needed for a singleton, and it's not as clear what it does. The main problems stem from the class being its own base class. First, isn't it weird to have a class be a subclass of a nearly identical class with the same name that exists only in its _class attribute? This also means that you can't define any methods that call the method of the same name on their base class with super because they will recurse. This means your class can't customize _new_, and can't derive from any classes that need _init_ called on them. When to use the singleton pattern. Your use case is one of the better examples of wanting to use a singleton. You say in one of the comments to me logging has always seemed a natural candidate for singletons. You're absolutely right. When people say singletons are bad, the most common reason is they are implicit shared state. While with global variables and top-level module imports are explicit shared state, other objects that are passed around are generally instantiated. This is a good point, with two exceptions. The first, and one that gets mentioned in various places, is when the singletons are constant. Use of global constants, especially enums, is widely accepted, and considered sane because no matter what, none of the users can mess them up for any other user. This is equally true for a constant singleton. The second exception, which get mentioned less, is the opposite, when the singleton is only a data sink, not a data source, directly or indirectly. This is why loggers feel like a natural use for singletons. As the various users are not changing the loggers in ways other users will care about, there is not really shared state. This negates the primary argument against the singleton pattern, and makes them a reasonable choice because of their ease of use for the task. Here is a quote from this URL. Now, there is one kind of singleton which is okay. That is a singleton where all of the reachable objects are immutable. If all objects are immutable, then singleton has no global state, as everything is constant. But it is so easy to turn this kind of singleton into mutable one, it is very slippery slope. Therefore, I am against these singletons too, not because they are bad, but because it is very easy for them to go bad. As a side note, Java enumeration are just these kind of singletons. As long as you don't put state into your enumeration you are okay, so please don't. The other kind of singletons, which are semi-acceptable, are those which don't affect the execution of your code, they have no side effects. Logging is perfect example. It is loaded with singletons and global state. It is acceptable, as in it will not hurt you, because your application does not behave any different whether or not a given logger is enabled. The information here flows one way, from your application into the logger. Even thought loggers are global state since no information flows from loggers into your application, loggers are acceptable. You should still inject your logger if you want your test to assert that something is getting logged, but in general loggers are not harmful despite being full of state.
Modules are imported only once, everything else is overthinking. Don't use singletons and try not to use globals.
Use a module. It is imported only once. Define some global variables in it. There will be singletons attributes. Add some functions, the singletons methods.